Hello everyone, we are the team of the rat protein tracker and we will now present our project.
Well, first of all, let's introduce us as Michelle as project director, Álvaro Corona as project manager, Iñaki Quesada as software developer, Hades Mantilla as quality and assurance engineer, Alejandra Velasco as software architecture, and Andrea UX as engineer.
So now we will explain our problem/background. So basically, at the Memory Research Laboratory at UNAM, they have a very big problem. Basically, out of 8,500 subjects, rat subjects that they have been studying, only 4,658 records exist. Why? Well, we'll explain that in a minute, but basically, this is a 68% reliability on the records that they are doing in the rats. So basically, they study the rats' brains, and due to different circumstances, they are losing many records. So our objective is to increase from 68% to 80%. That will be our goal.
Well, let's talk about our studies. Well, we have two studies, but we are going to focus in this part of the problem. Well, we have 35% of illegibility, handwriting. Then we have another problem that is 11.5% no centralization. And then we have another 20.8% of environment factors. And of course, we have 44.8 adherence from with rules in this part. So we are focusing this.
Okay, let's now present our main stakeholders. So we have indirect users, which are the ones that are going to be directly interacting with our system. And here we have the researchers, the technicians of the research laboratory and research assistant, right? And also the director of the memory research laboratory. We have the sponsors, which are the ones in charge of financially providing for our system. And here we have the UNAM and also director of the research laboratory. We have our indirect users, which are the ones that are going to be impacted or affected by our system. And here we have animal rights supporters, animal rights NGOs, people with memory-related illnesses, which are going to be the ones benefited from this system in the future, and also international scientific community. And also, of course, our rule makers, which are the organizations in charge of creating the rules for our system. And here we have SQL, COFEPRIS, Secretaría de Salud, and of course, directors of the memory research laboratory.
Well, now talking about our high-level objectives. The first one is that we want to increase the reliability of the information on 80% within 6 months of the software implementation. And we will be measuring this with the amount of records available in the laboratory. And then we have the second high-level objective, that is reducing the established research timeline from 18 years to 12 years. And we will be measuring this by the increasing the volume of records compared to the experimental capacity of the rats.
Well, let's talk about our third one. It is to increase the efficiency of the achievement of 60% more. And well, our scale is, of course, the rat sample subject. It's basically one of the highest objectives.
Then we have the main features of this. First of all, the first is that we want to register each rat subject. Also, we need to be able to delete, view, or modify the registries, to filter and group these registries by some parameters, different parameters, and finally to apply a statistical or mathematical model.
Okay, so we will talk a little about our current state. Nowadays, we have like 5 stages in which all the process is carried out. The first one is to record the subject training data. Nowadays, they do the register manually in a form, and they take the form, register the profile without the protein saturation, and they put it in a stack. The second part is
the categorization of the information when they take each stack and divide it according to their needs, and this leads to actually protein saturation, that is the results of the investigation. And they take each record or search each record by the RAT number and register the protein saturation also manually. The third one is the information verification, where a researcher take all the information and take a quick look into all the stack, and it pass it from one stack to another, and like only visually looks if there's like a visual error. If not, it passes. If not, it divides and it corrects it. And the third one is the tonalized data. The researcher inputs the data into an Excel, and in Excel it generates a statistical model.
Now we have the context, which is mainly centered in the main PC, which is used by the laboratory researchers and the assistant researchers. The main PC is connected to a special microscope that extracts the protein from the images, and the images are processed by a software called Fiji, which extracts the protein from the images. And here is where our project takes place, the rat protein tracker, which will be used in the main PC, which uses Excel for data registers and OneDrive for backup, so we don't have lost registers.
Okay, so now we shall present the functional and non-functional requirements while also presenting the prototype. So this is a video that we took of basically our prototype working. Okay, there we go. So the first non-functional requirement would be security, meaning the password. In order for the person to enter, or the research assistant or researcher to enter, they have to input the correct username as well as password. We can see we put Mitch1234, and that didn't work, so that's a demonstration of the first non-functional requirement. But then if you put UNAM, oh, that's different. Because if you put iniciar sesión, se le gustó. Oh, there we go, now it works. So, second functional, non-functional requirement, security editing password. So basically, in order to unprotect the sheet, you have to input a second password, which is only available for the researchers, not the research assistants. Okay, so this is another part of the prototype. Functional requirements shall register subject training data. So here, now it's different, and you can actually only input the stuff that the software itself allows. Basically, for the type of training, it's 0, 1, 3, and for the manipulators, it's only the ones that are currently at the research center. And that would be the other functional requirement. And for the areas of the brain, we have 4 areas of the brain, and you cannot input anything else. So as you can see, we inputted something that was not allowed, and the software told us basically it's not allowed. That's how it works. So we click register. There we go. And now also, if we want to actually change the protein saturation, because as you remember, we first register the rat, and after that, we actually register the protein saturation. So we input the second password that we mentioned, and then once you have inputted it, you cannot delete anything, basically, because, oh, well, also there's an automatic ID that we didn't mention, but basically they do not have to worry about the IDs, because when they input it, it automatically generates them. But you cannot delete any of the subjects, but you can actually register the results of the experiment of the protein saturation. So that's basically what we're doing right there. It has to be a value between 0 and 1. And also if you do not input a value between 0 and 1, then it doesn't work. There we go. And then also visualizing experimental progress, that's an unfortunate requirement. And we will see it in a second. The search is managed in less than 0.6 seconds, now with the 8,000 registries that we have. So it meets the non-functional requirement that it has to be fast, practically instant. So we can see.
if we don't have any search, we will have an empty field, and if we
Yes.
decide to search something that is not allowed, we will have a log message that we cannot put that parameter.
Yes. I didn't see it because. Okay, so there we go, super fast. And then another non-functional requirement shall perform data analysis. So we can see there a correlation model between all of the data that we have. So it also does the correlation in less than 0.9 seconds. And well, also in the memory research laboratory in the future, they will be able to modify these types of correlation methods. Right now.
And the user can navigate through the platform from each sheet to the other, like with all the liberty sheet or keyboard.
That's it.
Okay, so a little bit about the non-functional requirements that was not like visible in our prototype. The first one is availability. The system needs to be available from 8 to 6 and only 8 users allowed. The data integrity is made by a connection through the view and the model that is located in the macro through the controller, and it allows rollback, and this allows records accurately. Then the interoperability, that is to connect to Excel and all the Python libraries that we use to make the prototype. Then the security, the first password was for the let the user interact with the view, and the second password was for letting the view interact with the model through the controller. And the third one is scalability to handle 33,000 records, and performance, that is the ones we mentioned about searching, analyzing, and showing results.
Okay, so architecture, as we talked, now our architecture is called 3 components plus ETL. We chose it because we were looking for collaboration between the modules, and that the modules have different responsibilities, which helps to have easier maintenance, but also to make the software scalable. And we were also looking for the optimization of the user's experience.
Basically, to be frank.
Our 3 components are model, which is the Vision Basic that we use. We also have the view, we use the counter, and the controller is Pywin. So basically, these are the 3 components of our architecture.
So, okay, explaining a little bit more about what these 3 components do. So the controller is basically going to be in charge of managing the user request, and it's either the user request that we have. And then we have the model, which is basically the logic core of the system. And here we have also, like, this model is in charge of updating the information to the database. And then we have the view, which is basically the one in charge to present this information to the user, the interface part, and the data display.
So in the model, we will have an ETL that is extract, transform, and load. We can see, for example, in a registry where the system extracts the information from our lake, transform it into data that the user wants. For example, if I only want to filter something, it transforms it to like accomplish that requirement, and it load through the view. And in the other way, from a record, it extracts the information from the view, transform it to make sure that it complies with the rules, and upload it from the data to the data lake. So it's like a flow that goes and returns. So we have in the model the extract from the cloud, from the registries, and from the search. Then the transformation is made through Python, VBA, and a statistical model. And then it's flowed or to the view or to the data lake. And our data lake is stored in a database in Excel.
Okay, so Why did we choose this architecture? First of all, because we have modularity, which is related into managing and training data, and we have this time response from 0.6 to 0.9, and this is one of our non-functional requirements, the performance one. Then we have also the efficiency in handling the records, and here this is also part of our non-functional requirement of scalability, and we have support backup and rollback. And also for our non-functional requirements of security, we have the password. As Michelle explained, we have these two passwords. And also because of the user interaction and this the independent testing for each company, which is also essential in this kind of project, and we can work separately because of the architecture.
So basically, for the impact part, our project, but also now research, we are both helping to have faster interventions for different neurodegenerative diseases, which can lead to potential new treatments for different mental illnesses such as ADHD, PTSD, Alzheimer, but also addictions. But most important, what we are looking for is public health, because we are looking to boost quality of life, but also improving mental health.
Thank you.